Okay, Google, stop. Morning. Oh. Morning, Ashanti. I can't hear you if you're saying anything, by the way. Good morning.
Good morning.
Ooh, there was like your voice came out really weird. Is your connection okay? I wonder if I just upgraded my internet here at home, and so I'm hoping it's not my end. It might be yours, but you're already doing the right thing by having your video off to help with that.
My internet is down right now.
Oh, are you using your phone or something?
Yes.
Oh, okay. That explains it. Well, we'll work with what we've got then. So, do you have some specific questions for me, or do you want to look at stuff together? What would you like to do?
I'm kind of confused with the topographs. I don't really understand much.
Okay.
I understood the first one that we went over with, but all the other ones I tried to do and I didn't really understand.
Didn't get it. Okay. That's fine. It's a whole bunch of new language, isn't it? So, it's a new skill. Okay, how do I get rid of this? Let me just quit that. And I'll open the lab and then we can look at it together. Okay.
I didn't really understand for the first. How did you write it?
Sorry, say that again, please.
How did you want us to highlight the map?
Which map are you talking about?
The first one, part one.
Okay, let me share my screen. Is that it? Wait. I think this looks like the lab. Okay. So this one you understood that we went over in class.
Yes, I'm not sure if I drew it out well enough.
Okay, do you want to show me what you've got?
Yes, I'll show you. I'm not sure if you can see.
Yeah, I just have to make the screen bigger. I might have to stop sharing this to do that. Okay, got it. So that's fine. If you're handwriting stuff, that's okay. Now, I can't read what you've written there. I see the line between the two plus marks.
Oh,
What do you say about it?
I'm going to write it down on the document online. This is just for me to write out for now on.
Oh, okay, that's fine. You know, these questions don't require a lot in terms of response. It's just really brief things just to make sure you're understanding the concepts before.
I understood it because we went over it, but I understood how it was supposed to go. But for the last question, because you wanted us to do a little bit of math.
That's right, for the slope, right.
Yeah.
So, well, yeah, you can calculate the slope. And did you see the document that I added to iLearn to help with that?
No, I did not see it.
Oh, okay.
But
Well, that's not this. Let me show you what I've got there.
but I think I did the math correctly, if I'm not sure.
Oh, okay. Explain it to me.
So what I did was 100 divided by 2,640, right?
That's
And
correct.
then for
You
the
need to make
first
sure
one,
they're in the same unit. So you've got feet and feet. So you're good.
yeah. And then for the next one, I did 20 divided by 640 to 2,640.
That's right.
So
Now,
there are two separate answers, right?
it is. So
Okay.
what you want to do to make that to make the number more useful to you, maybe multiply by each of those numbers by 100 so that it becomes a percentage.
So
So
each of the numbers after.
yeah, so what slope did you calculate for the 100 divided by 2640?
What did I get?
Yeah, what was the number?
0.0378.
Right, when you multiply by a 100, then you get to call that number a percentage. So it becomes 3% or 3 point something percent.
And did you want us to round?
You can round to the nearest tenth after you
Because I
convert
got
to
for the
percentage.
second one, I got 0.0075, but I just put or 0.008.
Yes, totally. Just round off and wait, so what was the last one you said? You got 0.00 what?
75.
75. Oh, I see. And you rounded to 8. And yeah. Okay. So the answer becomes basically the left-hand side map has a 3% slope, or a little more than a 3% slope. And the right-hand side map has a slope that is less than 1%, 0.8%, after you multiply by 100. Does that make sense to you?
Okay, so
you should get a bigger
okay, so
number.
it just turned out to be 0.8%.
Yeah. So this one comes out to a little over 3%. Is it 3.18 or something like that?
3.78 it says.
So round it to 3.8.
For the percentage?
Yeah, for the first one, go ahead and round to 3.8 and just call that the slope of this map, 3.8%. And then this one was the 0.8%. So in reality, neither of these is very steep terrain, is what that's telling you, because a 3% grade, you're only gaining 100 feet over the course of a half a mile. So if you think about going up a hill over the span of a half a mile, you're only going up 100
that means
feet, not much at all. So 3% makes sense for that, 3.8%.
So like when you get the slope isn't, the percentage makes the slope not go high enough or something like that?
I'm going to share the document that I created for you guys. Okay, because this lays it out. I worry that we're miscommunicating just because I can't point to things for you. But
I know, because I tried to ask one of the classmates if they can explain. They didn't really understand.
It wasn't working. Yeah.
Yeah,
Okay.
they didn't understand it either.
So I created this document for you.
Oh yeah, I looked at that.
Oh, you did? Okay.
It was kind of hard to still like pinpoint out how to identify maps and stuff.
Right, but well, you're doing it. You're doing it right. I just want to make sure you understand what you're doing. And it sounds like you're good to go. So for this one, I actually wrote it out. So this is the X direction. So this is like the horizontal direction. Here's the vertical direction. So you're going up 100 feet across a half a mile. That's 2,640 feet. So,
Oh, I see.
so this is the math here, how to do. It's basically rise over run. I should have maybe explained it like that, which turns out to be, let's see. This is, if I were to type in, this is the rise over the run.
What do you mean by y equals mx?
So that's just, I was trying to translate it into algebra. And if you've done slope in an algebra class before, you would recognize that. X is simply what I'm talking about. The X direction is the horizontal direction. Y is the vertical direction. So Y would be how much height you gain. X is how far you go in distance on the map. And so the math goes like this. You gain 100 feet. There's how far you go, 2,000. And this is the slope. M denotes the slope. So this would be, this is the rise equals slope times run here. Meaning that's the vertical direction. That's the horizontal direction. It's just the language that we tend to use for these things. So I'm trying to use that to help explain. So to solve for slope, you have to divide rise by run. And that's all I've done here. Solve for M. M equals 100 feet divided by 2,640, which you already did. And you got 0.03787878. You're going to round it to 0.038. And oh, where did I put? Oh, here. This is where I do it. So
Yes.
the slope, when you multiply by 100, you can give that number a percentage. So it's a 3.8% slope. And 3 degrees is tiny, right? It's a tiny amount.
Yes.
Where right, a circle is 360 degrees. So 3% is really small.
Yes.
Or 3 degrees is really small. Okay. That went down funny. All right. For the second one, same thing. You set it up exactly the same way. 20 feet divided by 2,640. You get this really small number. You're going to round it to, oh, I think you rounded it to 0.008, which is fine. I just did 7.76. And then when you multiply that by 100, you get 0.76% slope.
Yeah.
So that's smaller than the 3.8% slope. So this is less steep terrain. This is steeper terrain. Does that make sense?
Yes.
Good.
Yeah, I understand that. I'm just I want to get a little bit of help on if I drew it out right, like highlighted it right.
I don't think you need to worry about too much about that. Like as long as I saw that you drew a line between the 2 red pluses. So I know that you understand that
Yeah,
that's
to
the
like
distance that you're measuring. That's okay.
yes.
So you're good to go
But I
on
needed a little bit help on the next one.
next one. Yeah. Okay. So let's stop this one.
On the
I see
next one.
we've got other people joining us. Okay. So the next one is, I'll share that document now. Yeah, that's the right one. No, that's not the right one. That's the same one I had. Hi, everybody who just joined us. Okay, this is the lab. Okay, so we just went over this one, everyone who just got here. That's the one we did in class. I explain it in a document that's called Slope. in the lab folder. If you need help with that, we just went over it. I can do it again, but we're moving on to the second diagram now. Okay, so for this one, you really need that set of rules about contour lines that is in the slope document that I added. And it's specifically number 8, and we don't have to go open that right now. I'll read it to you. It's number 8 says, contour lines curve upstream when they cross a valley. This leads to the rule of V's. Where they cross streams, contour lines make V's that point upstream. Okay, so where are the V's that point upstream? Upstream, is that down the hill or up the hill?
I think guessing uphill.
Yeah, it's where the stream starts, uphill. So we're talking about starting at this peak here. It doesn't matter how high it is, but it happens to be marked with 2,574 feet. So now look at the contours that surround the mountain. There's this kind, this is the most pronounced one, where it curves really sharply toward that peak, right? Then these contours point away from the peak. And this is toward the peak, away from the peak. You see that again, toward, away. And this is even more gradual, but this is toward and away.
Yeah, I think the way I drew it.
So if you indicate,
I thought I drew it like this.
Oh, let me. The window's so tiny. Okay, I see. Yes. So which one did you indicate were the streams?
I didn't really understand that.
Okay, so that rule of V's that says that the contours point upstream or uphill, because streams, they start, gravity brings the water down, right? So it's starting uphill and it comes downhill. That's an easy geological concept. And you just know that from living.
I guess I can say the ridges are like the stream going upwards.
So if I were to point at this part right here, what is that feature? Is that a ridge or a valley? This one.
A valley?
I think it's a valley.
So let me read the rule of V's again. Contour lines curve upstream when they cross a valley. So where contours cross streams, they make a V that points upstream or uphill. So
that would be
a
V,
ridge, right? Then. This is a V shape. Well, this is a V shape, but it's easier to do this. This V shape, this is the point I'm talking about, my fingers. Those should point uphill. So if my hands are contours, it makes a V pointing uphill. And it should go the opposite way, away from the hill, when it's pointing downhill. So on this map, this set of contours indicates a stream, because the V shape formed by the contours tells you it points uphill, and therefore that's a stream. These guys over here, the contours point the opposite direction. They point downhill.
So that would be a ridge.
So this is a ridge.
So how would you explain that here?
So how would you explain? Well, you marked your map. So you can just simply write on your map which ones are the ridges and which ones are the streams, if you like, or which ones are the valleys.
So the ridges are the ones that that area right here.
Yeah, so they kind of go north, east, south, west. And then the valleys or the streams, if they've got water in them.
And they go inwards.
They go inwards. So that's this one, here, here, and here.
Yeah. Oh, I see. I see. Okay.
There are some visualization websites
So what was that
that
rule
might
again?
help.
It says,
The rule
because
of
it said,
V's. The rule
because
of
like
V.
when I was trying,
Yeah. Sorry, I'll wait and let you talk.
when I was trying to look for the rules, I kind of was kind of confused on which rules can help me figure out that
It
how
was
to determine the
yeah, it was number
streams
8.
in
Number yeah. Number 8 does that.
Okay. Can you read number 8 for me?
Read it. Contour lines curve
Oh
upstream
yeah, I want to.
when they cross a valley. That's the rule of V's, where the contours cross streams. The contour lines make
Wait, contour lines curve upstream. Say it again. It kind of like skipped.
sure. Sorry. Contour lines. Here, I'm gonna switch over sharing so I can show you the actual document. That'll be easier.
Okay.
Here it is.
Because I think I remember that one.
Yeah. So number 8, contour lines curve upstream when they cross a valley.
I have a question.
Go for it.
So like a river or a stream is between two valleys, right? In a ridge.
The stream would flow in a valley. So a
Oh.
valley, saying valley or stream is kind of one and the same. It's a
Oh.
valley if you would say valley if there's no stream in it. If there's actually water in it, then you would call it a stream, I guess. But the stream is in a valley anyway.
Okay. Because I'm like seeing images on the internet and it's like it's V-shaped and like so like the hill so the river or the stream is cutting through it, and then there's like a river, and then there's like kind of like hills like this.
Yeah.
So that's why I thought it would be between like valleys, but
I guess I don't understand your question, because where you're talking about like a stream cutting across a map, that is
yeah.
the valley.
So like if you can see here, I did valleys and ridges correctly, but like I thought that valleys, so there's these two valleys, and then the stream like or a river is in between them as it cuts through the mountain. That's what I thought.
So a stream would go down the center of the valley. So if you were
Yeah.
to connect the points of the V's, connect the points of the V's, and that's where the stream would go. It's just
Okay.
the lowest point on the topography. So if there was water, it's going to go to the lowest point. I know it kind of, this looking at maps actually requires that you know some geology already, right? Because we're talking about hills and streams and slopes, and so we're really digging into this right away, jumping into all these terms and ways of thinking. So this is a lot of new stuff, and I understand that. So we'll just take extra time with it. That's fine.
If we got any of these questions wrong in the lab and we already submitted it, could we turn it in again, or would it be better just to leave it wrong? Or
gosh, I think I let you, I don't know if you can submit again. I might have to change would you go real quick onto iLearn and see if it would let you?
yeah.
Because I think since
Yeah, you can do that.
you're able to,
Mm-hmm.
okay, then I would resubmit with the correct answer.
Okay.
It doesn't have to be the whole lab. If you just want to add an extra sheet or something, that's fine.
All right. And then if we resubmit, will it be counted as late, or would it
I'm
be
not counting anything late right now.
Okay.
I gave you a lot to do the first week. It turns out I gave you a lot. I thought it was going to be relatively short. But that's just me not having taught at the, the 200 class level for a while. So it takes me, I'm doing some catching up too, in terms of like learning where you guys are at. So we'll just take extra time, and don't worry about anything being late.
Okay, thank you.
Yeah. I just want to make sure that you get, the only thing I'm concerned about is that you get your labs in before we have that exam, the bigger quiz, basically, that we'll do every 3 or 4 weeks.
Mm-hmm.
So as long as you get them done by then, you're fine. Because I'll
Right.
want to post keys online for everybody.
Okay, sounds good.
Okay. So have we solved this question now? I don't think there's anything else it's asking. Which rules help you determine the locations of the ridges and the valleys? You could just say the rule of ease, or rule number 8, or whatever you want. Rule of ease would make
Yeah.
more sense, because like, what number 8?
Rule of which ones? You said
V.
rule of.
The V.
Oh, I see.
So right here on 8, it has rule of V's in quotes. That's what I'm talking about. That's what I'm saying. So all you need to do is indicate which are the ridges, which are the valleys. There are 4 of each. And then tell me how you know. And that's it for that question. So let's go. I'm going to stop sharing this screen. I'm going to go back to the lab, because I thought I was showing you the lab just for a second, but never mind. Oh, I have to let somebody in. What is it? Oh,
So I want to make sure I'm explaining this right.
yeah, you got
For
it.
the valleys go downstream.
Valleys are at the low points. So valleys show you like where the low points are on the map. And the streams would fill the valleys, fill those low points. Like right here on this map,
And
actually,
also for the
there are no streams indicated at all, right? If there was water, that's where it would fall, is in the valley. So I gave you that an extra diagram, and you guys have already drawn this, but I'll just show you again because I've got it.
because I want to make sure I explain it right.
Yeah. So this is my
I
diagram.
don't know if me saying that it goes.
I'm listening.
So basically, the valleys go downwards and the ridges go, or the valleys go inwards towards the stream.
The contours point uphill. Yeah. The contours point uphill where they cross a valley.
The contours are the valley. I'm confused.
The contours are just the lines.
So the valleys.
So when I say contour, I just mean this line. Like here's a bold black line right here, right? That goes around the whole thing. That's marked at 2,400 feet. So if we just look at that contour line, it points uphill where it crosses a valley. So it's pointing to that peak where it crosses this valley. That's all.
And then for the ridges,
Yeah, so like a blue, one of these blue ones.
points downhill.
It points downhill, yeah, away from the peak where it's going across the ridge, exactly. I'm gonna find a website that lets you play with
Okay.
manipulating contours, because
And
I
then
think
the
that
other
will
one
help you
is
understand.
towards the peak.
I didn't hear you say that, I'm sorry.
Okay, I understand that one. And
Good.
can you also explain the stream, the next one?
Yes, let's do that one.
Because I didn't understand how to get those calculations. I was trying, but
You mean for slope?
yes.
Okay,
No, for the
this one.
basically,
This
yeah.
one.
Yeah,
Okay.
that one.
Okay, so this one, it gives you, I'm just going to read the problem. The topographic map above shows 2 streams. Okay, so those are the ones that are marked in blue. And it says, what is the upstream direction for each stream? So we need to figure out, is the upstream direction this way or that way for that one? Or is it that way or that way for this one? So we can
I think it's going towards B.
say that again, you cut out.
Where B is.
Where B is.
I think it's going towards B.
Well, they're going past B, so what do you mean?
Yes.
So let's
Upstream.
identify B and
That little, it
A
kind
and
of
B
looks like
first.
an arrow.
Let's identify the landforms that are A and B first. That might help a little bit. Okay,
Oh, B is a hill and A is a depression.
that's right. So B represents a hill because there's the contour forms a circle or an oval of sorts, more like a weird egg. And then where the same thing goes for depression, just like a little bowl in the landscape. And you get these hash marks here that tell you that's a depression. So they're both like ovals or circle shapes, but you get the hash marks where it's a depression. So that's how you know A is a depression and B is a hill. That's also in the rule of the contours. It specifies that there too in that document. I got that from the web page here, this rule of contour lines page. So that's where that's from. Okay, so now that we know this is a depression, that's a hill. The streams are going around a hill, which makes sense. They're not going to go across the hill and then back down. They're going to find the lowest place on the map and follow that route because gravity is pulling water down all the time. So it's going to flow in the lowest points on the map. So all we're going to do is now decide are they both coming from this direction and flowing to this direction? Vice versa? Are they flowing different directions? So that's what we're trying to figure out.
I think they're flowing different directions because that one looks like a hill too. The other one, yeah.
This is a hill. Yeah, exactly. This looks like it's part of a circle and the streams are going around the hill. Exactly. Okay, so, but we're gonna use the rule of V's to figure this out. Okay, so what did we just learn? V's point uphill. The contours form V's that point uphill when they cross a valley or a stream. So where can we find V's on this diagram related to those streams? Here is one. Here's another one. The tip is cut off.
And then on the other side where it says topograph map.
Yeah, right
Yeah.
here and here. Okay, so the V's, the contour, let me say that again.
Is that how you answer basically number one, what is the upstream direction for each stream?
Yes.
Where the V's are?
Well, so you need to use the rule of V's to figure out which direction it is. Are they flowing to the left? Are they flowing to the right? So let's look at this one. So you think it's flowing to the left?
Yes.
So let me read the rule of V's again. I'm not reading it. I'm explaining it. Okay, so the contour lines form a V that point uphill or upstream where they cross a valley. So this V, there's the V, it's pointing left. So that's upstream.
Oh, so I see. So it's going upstream. Basically, it's not going left or right.
Well, so one side of the map is higher than the other. We just don't know which yet. So that's why we're using the rule of V's. This points uphill. So what I'm saying is both of these, it looks like both of these streams are flowing the same direction. They're both flowing to the right. If we go back to this one, remember the V's point uphill. So if there was a stream, I would draw it in here, like I would just connect the points of the V to draw in a stream. They're pointing uphill. So the open part of the V is downhill. So come here, the points are pointing to the left, the upper left and the lower left. That means downhill is over here on the right-hand side. This map is indicating a fairly flat area. These contours are widely spaced and it's pretty flat in here. The stream even starts to meander. We haven't done streams yet, but streams start to meander where you get like a flat valley, but then it gets steeper again here. So what we're seeing
So
is
uphill is toward the left, uphill.
here. This is uphill and this is uphill. Up elevation. So the elevation's getting higher going that way. Now that makes sense because look at this contour. 1,040 feet here. You're supposed to fill in the blanks for these contour lines. And so now we know this is a hill, so you should be adding to that elevation to mark this contour. So it says it's a 20-foot contour interval right there. That means this contour is at what elevation?
It's 1060.
1060, right. And then this one would be 1020.
Yeah.
1,000.
Yeah.
How do you
about
figure that out?
That's what I didn't get.
So how do we figure that out? Number one, we see that the streams are flowing uphill, so that's the uphill direction, and they're flowing around this feature, which is also a hill. We're seeing kind of like a half circle, and so it's indicating to us it's kind of like these circles here. We're seeing just part of it, but that's indicating a hill shape there.
Yeah. So what about the other numbers?
Where do you go here? So this line, okay, so the nice thing about contours is that you can follow them around. So what was the elevation for this line again?
1,000.
1,000. So follow this one around. It's always at 1,000 feet. So mark 1,000 here as well.
Okay, perfect.
Same thing over on this side. Follow that contour around, mark 1,000 there as well.
Okay. Oh, is that connected? I thought it wasn't because
Yeah, it's connected.
Okay.
It would be a little bit easier if they would connect that one for you, but that's the idea. So then you should be able to figure out these contours now.
Wait, I'm very confused. How'd you guys get 1,000?
So because the map says at the bottom in the legend, it says contour interval is 20 feet. So we are given 1,040 feet here. And if we know that this is the downhill direction, then we're simply subtracting 20 feet for every contour. Sorry, I shouldn't say simply because it's not simple the first time you do this. 1040, subtract 20, you get 1020. Subtract another 20, you get 1,000.
And then you add 20 going downwards. Oh, I see.
Say that again. So
And you added 20 to get 1,060.
that's right. You add to get 1060 here. Then you follow the contour around to this side and you
Yeah.
put 1,000 here again. Now this goes uphill again. We're going up.
So you would have to add.
But then there's so you have to add again. But wait, this feature, there's a ridge here because there's a depression in the top of it. So this is the next contour, except it goes down from there. So you would mark 1,000, 1,020, 1,040. What's the one inside with the A? It's a depression. So what happens to the elevation again? Tell you what, let's do the hill first. Let's go to the other side. Let's do B first. This is 1,000. We'll come around, zoop, this one, add 1,000 here. And then we're gonna move towards the B feature. Well, actually, let's do this one. So if this is 1,000, what is this contour above it and the one above that? This is a low point. So presumably,
1,020.
yeah, so it should be 1,020 here and
1,060.
40, just 40, add another 20.
Oh, sorry.
So
And then
1,000,
1,060.
1020, 1040. Yeah. And then if this is 1,000, we're going to go downhill towards the stream. So this one should be what?
980.
980. Subtract 20 from 1,000.
Oh.
980. So that contour is the same around here. So it's 980 here as well. So if you were to cross a creek, you drop down into the creek and then you have to come back out the creek. That's what we're doing. So that's the same elevation. So this is we said 980, right? 980, 980. But this feature is a hill. So we got to go up again. So this contour is.
How are they both 980?
Because it's the same line.
How are they? Okay.
See how it connects there? You follow it around?
Yes.
So that's the whole idea of the contours, is that they connect places that have the equal elevation. So if you just use that fact and follow them around, you can see that this is 1,000. This is a hill, so you need to add 20 to get the contour, the elevation for this contour. So this should be 1,020 for B. Well, the hill's probably above 1,020, but we can't see exactly how. But it's not 1,040, or else it'd be another contour.
Just a second. So
Wait, I thought they both were 980.
This is 980, this is 980, right? And then this one is 1,000. We're going back uphill. They're really testing your knowledge in this little diagram. They ramped up the difficulty quite a bit from this one. Is everybody with me on this hill, the contours for this hill and the contours for this side, the top part? Or does,
yes, I'm just a little confused about where the depression for A.
So let's do A now. Let's do A. So we did the hill. So let's come around. We know this is the 1,000-foot contour still.
Yes.
Right, 1,000 in here.
Yes.
We're going this long feature, and the fact that there's a depression in it, this is a ridge. It's showing you there's a long area of sort of equal elevation here, and there's a bowl shape in the top of the hill. So this should be the, oh wait.
I don't know if it's going down or.
We should go down. So this is, if this is this is 1,000, this is 1,020.
Why is it 1,020? It should be 980, right? Because we are going down towards a depression.
Oh, you think it's a valley? No, it's going up because we're moving away from the valley. This is the valley here
Oh.
where the stream is. So we're moving uphill again away from that stream.
Because I read that like if there's a point, so a contour line above it would always be greater and the contour line below it would always be like less.
That's correct.
Yes, that's why I thought it would be 980.
Wait,
If
so are
this,
these,
if we
these
go down,
lines that we are adding,
we know that this contour is 980 because we deduced it from calling this one 1,000, working our way around, and then we know we have to go downhill toward the valley where the stream is. So this one is 980. So this entire line is 980. And we're coming back uphill again from the stream.
That makes sense.
That's how to read that.
Okay.
And then it's going uphill a little bit more. And then we run into this depression. So let me read the rule of the contours for depressions. It says depressions that have no outlet are signified by closed contours, meaning like a rounded contour, with short lines that stick out and point toward the center. That's what these hatch marks are. Tick marks, hatch marks, hashers, they're given all those names. So this contour here should be less than this contour. So what elevation are we there?
Pardon, I cut out. What did you say?
I'm asking, these hatch marks tell you that this is a depression and not a hill.
Yeah.
So when we came up to this hill, we kept adding elevation until we got to B, and then we had to stop. That's the top of the hill.
Yeah.
Here, it's telling us it's not a regular contour. We're gonna subtract instead.
Yeah. So it's a 1,000.
Yes. So this is again at 1,000, and then the inner one.
980.
Yes. Okay. Now, because this is indicating the top of a topographical feature, because they're enclosed circles. So this whole thing is a ridge that it's on. So that means we're going to go down in elevation. So this contour should be the same as this contour. We're going down the other side of this ridge. So if this was 1,000, that's 1,020. This should also be 1,000, and this was also 1,000. This should be 1,020.
Because we went up again, right?
And then this is 1,000 again.
Pardon? So,
So this line, I'm sorry, somebody's saying something and cutting out. Ashanti, I think you're talking, but you're cutting out a lot. Try that again. Uh-oh. Oh dear. Okay, just pause for a second because I can't hear anything you're saying. I don't know if that's me or if that's your cell phone connection. Try that again, Ashanti. I think that was you.
That again?
I heard somebody.
I can hear
I
about
could
it.
hear you when you explained the contours next to A.
The contours next to A. Okay, so because they have these tick marks on them, it means it's not a regular contour. It goes down in elevation instead. So instead of continuing uphill, so we got 1,000, 1,020, instead of calling this 1,040, we're gonna go back down to 1,000 because it's a
And then
depression.
980.
And 980 in the center, yes.
And then I meant to these lines next to it. What do you call these lines again? The ones that we're adding numbers? They're valleys, right?
I'm not sure which one you're talking about. All of
Right there.
this,
Yeah.
so this is just call it a contour line.
Okay. Yeah.
It doesn't mean anything right now except that that's a line of equal elevation. So, but what we're doing is starting to go downhill, what that indicates. So this is like the top of a long ridge. We came up the side of a long ridge. At the top, we found like a bowl-shaped depression, and now we're coming down the other side of the ridge. So
this would be 1,000 and
this contour and this contour should be the same.
1,020.
Yes, and this contour and that contour should be the same. So 1,020 and 1,000 again.
Why is that?
Okay, I see.
Should it be 1,000 and 1,000 again? I didn't get it.
This one and this one are on opposite sides of the same hill.
Okay, so it's a depression and then it's, oh, okay.
So it's like if you can watch me a little bit, I'll try to demonstrate. Like the side with the stream, we'll start there. You're down at the stream valley. You come up the hill and you're passing two contours. You get to the top of the hill and there's a depression in the top. And then you continue on the other side and come down the hill again. So you're coming uphill from the stream. And then this is one big flat area at the top of the hill, except there's this little depression, a bowl. And then we're coming back down the opposite side. So the same as this. This one is the same as this. This one is the same elevation as this.
Okay, that makes sense. Thank you.
Is everybody on the same page with me? I mean, meaning, do you agree? Does everybody understand how we figured out the two hills and the bowl-shaped depression on this map?
Yes.
How we figured out the stream directions using the rule of V's, and how we figured out the contour line elevations.
Yes, I understand that.
Everyone's good? Okay, awesome. If you didn't say anything and you're not clear, say something, please.
Well, actually, I just got here because I was just in a class. So
Okay. Where are you starting from? Where are you at in this lab?
I am at the ridges and valleys.
This one, the problem diagram 2?
Yeah, diagram 2.
Okay. I'm going to come back to that, please, because we just did that, and we just finished diagram 3, I think, although I didn't hear that. I think Michael and Nandita, I think you were here already. Maybe Jasmine? Wait, I don't know who's who. Whoever else was here just now, are you okay with this one? Can we move on?
Yeah.
Yeah, I'm okay with that one.
Good. Thank you. Okay, let's try this one. It's a different kind of problem. So, sorry, was it Michael or Davina who just got here?
I just got here. Yeah, Michael.
Michael. Okay.
I just got here too.
Oh, okay, cool. So this is a different kind of problem. It doesn't build on the rule of V's or anything. So we'll go back and do 2 and 3 separately after this.
Also for diagram 4, when I downloaded it onto my laptop, like both of the diagrams were cut off for me. but I'm sure like it's I think it's just
So
kind of what happened to
it,
mine.
it
but-
could be formatting in the Word document that's the problem. If you click on the diagram, you should be able to paste it somewhere else.
Oh, okay.
It
Thank
should
you.
be there, even if it's like cut off funny.
All
So
right.
try copying and pasting it somewhere on another page.
Okay.
For some reason, I can't see your screen.
You can't see my screen? I'll stop the share and start again, just in case. Okay.
Now I can. It just
Good.
it cut off, so like I'm not able to even see it.
Okay.
The way
But
I
you-
printed it out on the computer, it's cut off. But I can just look
Okay.
at your screen.
Okay. Fine. So do the same thing, like copy and paste or something, or you could print out a PDF instead of a Word document, and that should preserve any formatting too. And then you can hand draw or use other drawing tools on top of, or in Acrobat, actually. There's a pencil you can use. But let me explain how to do this. Okay, so here's the example that they're using. On this map, you guys, this is a cross section. So it's like we're cutting through the earth and looking at the side of this map. So it's like the map is up here and we're looking below the surface. And what we're doing is seeing that this landform is part of a hill, the side of a hill. This landform is a hill. And then we go up a hill on this side, and then there are two valleys. See the V's? So this is not part of the question, but which way would a stream flow in these two streams? Are they going to go up or down? Which direction are they flowing in? Where is downhill on those two valleys? On the bottom of the map or the top of the map?
I think the bottom.
Bottom.
Yeah. Because of the V's, right?
Yeah, and also like streams always flow down.
Of
Downhill.
course. Yeah. You also see the contours that tell you there are contours there too. I wasn't thinking about that. 400, 500, 600. Yeah, it's gonna flow downhill, flow down elevation. But if you didn't have the contour lines labeled, you could figure it out because of the rule of V's, right? Because the V's are pointing upstream. And so we know that that's uphill somewhere up here and they're flowing this way. Okay. I just was checking to make sure you guys were on the same page. Okay, so we're gonna do the same thing with this manufactured topography. So this is gonna be a lot smoother for us, but a similar kind of thing. So what does this look like to you? If you were to describe the landforms on this map with the AB cross section, what do you think it would look like? Before we
It
start, just
looks
to get an idea.
similar to the last one, but except the contours are closed and we don't have to put numbers, I guess.
Yeah, so you just told me basically that you understand that these are two hills, right? You just interpreted these as two hills, I think.
Yeah.
Yeah, that's great. That's already progress in the course of sitting here and doing this lab. So
Yeah.
I'm impressed. That's great. Okay, so in order to do this, we are drawing a line between A and B. So let me see if I can find a tool. Draw a line. Uh-oh. That's not good. Okay. I might have to draw this a little bit by hand, or you know what, tell you what, I'm gonna print this page out. I have a new device here. It's a document camera, so I can draw and show you guys. So let me just print this real quick. And I'll grab it, and then doing it by hand should help.
Excuse me.
Go ahead.
I just did mine. You mind if I can share it?
Oh, absolutely. Yeah, go ahead.
Yeah, I just let me just.
Do you show how you did it, like by dropping the lines down and everything?
Yes, I got this one.
Awesome.
Yeah, just want to show it to you, just check it.
You should be able to. Oh, I have to stop sharing though. There you go.
Yeah, this is mine.
Awesome. Can you zoom in a little so that I can, yeah, just so it fills the screen? Yeah, perfect, perfect. Awesome. That's exactly what I was going to show. Okay, so you're creating a profile from point A to point B. And you've done this is exactly correct. So you're starting off with the bit of information that this heavy contour is 500 feet. And so, and this is 400 feet. So everywhere that your profile line intersects a contour line, you need to drop a vertical line down to the correct elevation that that contour represents. So you should label the contours, or at least know what the contours mean. This is a 20-foot contour interval, right? There are 5 in between the 400 and 500. So this is 420, 440, 460, 480, 500, 520. Everyone with me?
Yeah.
Good. Okay. You can also do the little thumbs up or a yes
How
mark
do you
or
how do
something.
you figure out what line goes where?
Hang on. I think that's the next step. Okay, so if we start off with the 500-foot contour right here, it intersects our profile line in 2 places, right there and right there. So we're gonna drop a line down vertically.
It's still on his screen.
Sorry?
It's still on his screen.
Oh, that's right. Oh my God, you can't see. Oh, could you point to what I'm talking about?
Okay.
Yes, thank you. Can you point to the 500-foot contour, please, and show where it intersects the, okay, right
Is
there.
it?
So it points right there. Could you show dropping it down vertically from that? Yeah,
Right here.
it's right there. And that should hit the 500-foot elevation line. So you stop there and you make a point. You just make a little circle right there. And then this one's uphill of it, the enclosed circle uphill of the 500-foot contour. Yeah, that is at 520 feet. So drop the line down and it should be to 520 feet. You mark another circle, like another point there. And you do that for everywhere that a contour intersects that profile line, and then you connect the dots.
How do you figure out that though?
Oh wait, I can't see like anybody's camera or the screen, so I'm gonna leave and then I'm gonna come back for a second. Sorry.
Sure, absolutely. Yeah. Okay. Figure out what the contour intervals, what elevation the contours are for.
Yes.
Okay, we're figuring that out based on the fact that, did you write in contour interval there, or did it say that already?
I wrote it down.
Oh, okay. Then you figure it out because this is the 2 bold contours are labeled 400 and 500 feet. And so there are 4 contours in between. So each one represents 20 feet. So the first, like 400, if you count by 20s, 420, 440, 460, 480, 500. You should be able to count those contours from 400 to 500 on that hill. And then in the same way that we worked out the value of the other contours on the other maps, we do the same thing. So the 420, could you point to the 400? Actually, I'm going to stop. Can you stop sharing yours? And I'm going to go back to mine, please.
Okay.
Thanks. Thanks very much for doing that. That was great. Okay, so this line is 400 all the way around. And we know that that's the same line because it's still bold, just like this one is. It's called an index contour when they are bold like that. Okay, so you got to count up 420, 440, 460, 480, 500. It didn't tell you that, but if you divide 100 by 5, by 1, 2, 3, 4, 5 contours, you get 20. So and they're usually a round number, right? So, and 20 is a common one, or 100 might be another common contour interval.
So where would you start at?
Well, you could start with 400. And so that one's 400, and that means this line is 420 all the way around. So that's 420.
So which line, can you show me again, which line is 400?
The one that's labeled 400?
So
Here?
you would go down to 400?
Up. These are hills. Remember? We know that this is 500, so that means this is a hill. And they're enclosed circles, just like we were looking at other hill features. You with me?
I'm a little confused.
Okay. Can you ask the question differently to tell me where you're confused?
I'm just a little confused about how do you figure out which line goes where down at the graph at the bottom?
I see. Okay. So let me just talk about the contours real quick, because I want you to label your contours to make it easier to do the profile.
Okay.
Okay, so that's 400, that's 420 everywhere. This is 440, so is that. This is 460, so is that. This is 480, so is that. This hill is higher. It goes to 500 and then to 520.
In the middle
In the center of the 500 contour, right.
for both of them.
No, this one doesn't go all the way to 500.
Oh, yeah.
There's one less contour there. Okay, so take a ruler or the edge of a piece of paper or the
But
edge
it goes
of
to
a Sharpie.
500, right?
Say that again?
It goes to 500, right?
This hill only goes to 480. This one goes to 520. This is 400, 420, 460, 400, 420, 40, 60, 80. So that's 480.
Wait, say that again?
400,
400,
420, 440, 460, 480. I'm just adding 20.
But what about the middle?
So the middle is just, it's somewhere between 420 and 440. It's kind of flat.
No, the middle of
It's telling you it's not as high as 500. It's somewhere between 480 and 500 is what that's telling you. So there's probably a kind of a flattish top to that hill that doesn't reach 500 feet. But this one is a little bit higher. Okay, so make a note to yourself that the contour interval is 20 feet. Okay, then draw this line and make it straight. Make sure you're using a ruler, anything straight. It can be a box edge or an edge of a pack of like sticky notes, anything you got, pencil, and draw in the line between A and B. And then from left to right, now that you've got your contours labeled, go from left to right, from A to B. What elevation is this contour right here? Anyone?
Sorry, what's the question again?
What's the elevation of this contour right here?
It's
20.
420.
420. So we're gonna drop, take your ruler or whatever straight edge you're using, drop a straight vertical line down to 420 and put a dot right there. A nice big dot so you can see it. And then we're gonna move to this contour here. It intersects the profile line there. That's a 440 elevation contour. Drop a vertical line, and it really does need to be vertical. And when you intersect 440, put a dot.
I can't see your screen.
Oh no,
Oh, wait.
again. Okay, let me stop and share, reshare. Okay, is that better? Okay, so I hope everyone can see the screen. You're just gonna make a progression of dots
Yes.
that everywhere that a contour intersects that profile, the AB profile line, you're gonna drop a vertical line down and make a dot, another dot,
Yeah.
right? And
How will we
this is gonna
be
go up
able to do the one that's between 480 and
oh, how do you end your hill? Yeah, I get it. Okay, so this one is 480. So you're gonna have a dot at 480 here and another dot at 480 here. So you're gonna make your
what
hill.
about where 480?
Do you want to label your lines here? 420,
What about
440?
where 480 and 500?
So I think I understand your question. Make sure you label your lines so you're getting the right line. But for this feature, it's going to be a hill that connects the two 480s, but that doesn't reach the 500-foot
So
contour.
just two 480s for like the middle circle?
Yes. It's going to be 480 on the left, 480 on the right, and you're going to make a little hill to connect them. But the hill should not intersect the 500-foot contour. See that right here on the
I
profile?
see what you're saying.
Okay. And
I see
then
what you're saying.
you're going to come down in elevation to this little valley in between the hills. So you're going to go 480, 460, 440. And so you're going to have dots that go bop, bop, bop. Then you're going to have another one over here at the same elevation, another 440. So you're going to make a little dip that doesn't reach 420, but 440 to 440. And then start going up your hill, basically. So you're going to go uphill, 440, 460, 485, 520. So this one's going to be up here, 520 there, a 520 there. And you're going to make a little hill that doesn't reach 540. And then do the same thing. Make your other dots that go back down to 420 on this side. And then what you do is literally sketch in a straight line, or you can get a little artistic, but if you were to sketch in a straight line between each set of dots, I would round it when you get to the top of a hill and round it when you get to the bottom of a valley. And then you have a profile. Is everybody understanding the process? Or tell you what, maybe a better question is, okay, good. Yeah, especially the one who, I can't remember who showed me, but yeah, that was correct. The example that we saw, that looked good. So if you come up with something that's close to that, that's right. Hopefully you're drawing vertical lines and they're not like going off. If you hand draw them in, if you just try to sketch it, it's probably going to look kind of shitty, but it's a lot nicer if you use a ruler or just, like I said, anything, a pencil to make a straight line. And then just connect the dots, and that's your profile. So the only thing missing from this example, they drew the AA prime contour line there, is they didn't drop the contours down and mark them on this diagram. But you could do the same thing here and put a dot where it intersects, put another line, another dot where it intersects, and it would turn out just like that. So yours is going to look similar, but it's going to be smoother. So if any of you guys have already done a question that we're going over, you're free to just hang out and wait till we get to the next question, or to check out, like just let your screen be, mute yourself, whatever, go away for 10 minutes. come back and we can get to the next question.
So what steps did we take to do this? Because it's not the same as, is it the same as the other one?
Yeah.
Rule 8?
They're the same. I mean, it's the same process. Yeah. Oh, I see, because it asks you what steps. So the steps that you need to take are to draw a line between A and B. That's your cross-section line, your profile line. And then you're going to, everywhere a contour crosses that profile line, drop a vertical line down to this graph and mark the correct elevation for that contour. Mark a dot on the correct elevation. And then you connect the dots after you've done all that.
I do have a real quick question. Would you rather us do this on Google Docs or
I
actually
see.
put it out?
It's kind of up to you. It'd probably be a lot faster to just do it by hand, honestly. But
Okay.
I mean, if this is the only problem that you do by hand, you can take a picture of it and then put it back into your lab doc.
Okay.
Yeah, you can just like delete these, put your worked problem right back in the Word doc and turn that in like that. That's totally fine. In fact, I would probably do it by hand myself because it's that much faster instead of like messing around with trying to draw on top of this graph. You saw how successful that wasn't the first time I tried. Does anyone want to see me do this by hand? Or is this explanation good enough and the worked example that you saw? I'm happy to do it by hand.
I'm good.
I'm good.
Cool, okay. Should we just keep going on this lab?
It's good enough.
Sorry, I didn't hear that answer. I assume yes, we should just keep going.
Yeah, yes, we should.
Okay, let's do that. I'm gonna zoom out a little bit so I can see the whole problem. Okay, so we're getting some
Yes, we should.
color topographic map
Yeah.
examples here.
We should keep going.
Okay, good, thank you. All right, so a small portion of a topo map showing a road and a creek. So the creek is a blue-green line. This is a part of Seattle. We assume north is to the top. Using the rule of V's, determine which way the creek is flowing. You got this one, right? This is easy now, I think. So is the creek flowing up or down on this map? North or south?
Going south.
Yeah, it's flowing south. Remember, the V's point upstream. So it's coming from north and flowing south. Good job.
Black boxes are houses, right?
They are. Or buildings. Yeah, but probably houses.
Thank you.
Yeah, so this double set of black lines right here, that's a road.
So it's coming from north and flowing south, you said?
That's right. Just using the rule of V's. So the V's are pointing to the north. So that means it's flowing to the south. And you could work that out too. If we knew the elevation of these contours, we could figure that out because this contour at the bottom of the map would be at a lower elevation than this contour at the top.
Wait, you said the V's are coming north?
Same rule of V's. So the V's are pointing to the north on this map, right? The contours,
Yes.
the contours are forming V's that point north. That means that's the uphill direction. So you're gaining elevation going to the north. That means the streams always flow downhill. That's a fact of gravity. They're all trying to get to the ocean. That's what the ultimate goal of water on a surface is, to go down to one stream to the next stream to the next stream until you make it all the way to sea level. or below.
But aren't all of the, it says using rule V's determine which way the creek is flowing. That's the answer, right?
Yeah, you're using the rule of V. So, and do you understand that the V is pointing in the opposite direction of the flow?
And what are these little boxes? Are they like what are those called?
Take a guess.
Hills?
Nope. Here's a road.
Hills or valleys?
These black, so these two black lines here, this is a road. And next to the road are these black squares,
So it's cars.
houses. Cars move too much. Houses usually stay in
Oh.
one place.
So that's the answer, their houses?
Their houses are buildings, yeah. I suppose we don't know that they're houses. They could be commercial buildings, but yeah. And that's all that this question asks. So we could go to this one. Okay, we're making progress. This is another part of the same map. It says every fourth
This one's a little
contour,
tricky.
it says every fourth contour line is heavier and labeled with height in feet. Okay, so notice that here's one of the heavy contours that's darker brown. It's a bolder line. This is 100 feet. And then uphill, there's another bold line that says 200 feet. And then there are 4 lines in between. Aren't there? 1, 2, there are only 3 lines. Ah, this is a different contour interval. What's the contour interval on this map? It's not 20 feet.
100?
Well, that's between the index contours, between those heavy contour lines, yes. But what is the contour interval refers to the interval between each contour. So that includes all these little ones too. So if you were to count 100, 100 and something, 100 and something, 100 and something, 200, what's the contour interval? What's this contour line represent? The one just above 100. What's the elevation? And we know we're going uphill because we're moving away from the stream and we're moving towards this 200-foot contour.
Is it like 133 something?
Easier than that.
130?
It's 125.
125?
Yeah, so 125, 150, 175, 100. Yeah, so it's a 25-foot contour interval.
Shouldn't it be divided by 3, like 200 minus 100?
Well, you're counting the next bold line. So you're counting 1, 2, 3, and 4.
Oh, pardon?
You're counting all these lines. So if you're starting off with 100, you're counting 1, 2, 3, 4 lines in 100. Not 3 lines in 100. It's only 3
So
lines.
you're adding 25 or subtracting 25?
You're adding 25 or subtracting 25 every contour, yes.
Shouldn't it be 5 then? Because it's like 1, 2, 3, 4, 5.
It would, if there were 4 smaller lines, so
Yeah.
like the last map we had here, or sorry, this, wait, which one was it that this had? Okay, this is a 20-foot contour interval. It's got, start at 2400. There's 1, 2, 3, 4, 5. There are five contours in 100. So it's 100 divided by 5 to get your contour interval. If you were to only count the 4 in between, it wouldn't be for 100 feet. It would only be for 80 feet because you only got to the 80th foot contour there. So you got to count the next bold contour as well, the one that you're actually including. So count 1, 2, 3, 4, 5 in 100. Here in this one, you're counting 1, 2, 3, 4 in 100. So 25 feet. And because also it's usually a nice round number that ends in a 5 or a 0, never in a 33.333 or anything like that. That would be crazy. That would be impossible to like read easily, I think. Okay. I mean, you could do it, but it
How do you
wouldn't
de-
be nice.
how do you determine the elevation difference? Like, is it
Between what and what?
the two red arrows you're saying?
Okay, so we're starting that process. So we've established that it's a 25-foot contour interval, right? Right? So now I want you to look at we've seen the 100-foot contour, count down toward that stream from that 100-foot contour. So subtract 25 for each contour line you intersect.
Yeah.
Until you get to those red arrows. So if this is 100, what's this elevation that I'm pointing to? Right there, this line. You're going to subtract 25 from 100. So that's the,
Wait, are we actually doing the math here?
I'm asking you to, yes. Think about it like quarters, right? You're just taking a quarter out of a buck. So 75 cents, you're left with 75 there.
Because I don't really see where do we insert the answers. That's why.
You can just write on it. I don't think that there's any place for you to fill in the contours. It's just a step you need to take in order to answer the question. So there's 100, that's 75, that's 50, here's 25 feet, right?
Yes.
Okay, so the left-hand arrow is at 25 feet. Pointing to the left-hand arrow is pointing to the 25-foot contour. Okay, now we want to go over on the right-hand side, do the same thing. Let me zoom in. So this is really
Just because the way ours is, you can't really see where to put it because it's kind of a lot of lines everywhere.
Oh, because it's like, can you, on your computer, can you zoom in so you can see it better?
Because I'm using my paper right now, so I guess maybe it's the way it's printed.
Got you. It would be for the small diagrams, sometimes it would be easier to like look on the screen and blow them up so that you can actually read the tiny details. You can go back and do that afterwards, I suppose, if you don't have access to your computer right now.
Yeah, I'm just confused as to where do we start to do the subtracting and the adding.
So what we're doing is interpreting what we see on the map. So the question is counting on you to figure out some things. It's counting on you to figure out that the contour interval is 25 feet. And that's the first question, right? And then it's counting on you to figure out what the elevation of the contour is using that contour interval to figure out what the elevation at the two red arrows is. So we found out that the left-hand side red arrow is at 25 feet of elevation. So we're really close to sea level here. It's Seattle, so yeah. And we got to do the same thing over here. So on the right-hand red arrow, here's the 100-foot contour right there. What's that? What's the elevation of this contour at the right-hand red arrow?
75.
75 feet.
Yeah.
Okay. So the right-hand arrow is at 75 feet. The left-hand arrow is at 25 feet. Tell me which way that stream is flowing.
Wait, say that again?
The right-hand arrow, the red arrow, is at 75 feet. The left-hand arrow is at 25 feet.
It's flowing towards east, like towards the left.
Towards the left. That's right. So you could use the rule of V's also to figure that out, that this is pointing uphill in this direction. But we also know because the stream is at 75 feet here and the stream is at 25 feet there. So it means it's going from uphill, higher elevation to lower elevation.
So it should be like 50, right? The elevation difference.
It's 50 feet. That's right.
Thank you.
You're welcome. But never mind the answers to the actual questions right now. Do you understand how we got there?
I definitely understand. What I did was a bit of kind of like, I don't know, cheating, because like what I did was like, oh, that was 100, right? And so the 75 one is the same since contour lines follow. So where the red arrow is on the left side, I just thought that the 75 would be above like 100 and then 75, like just below the red arrow. Like,
Yeah.
And I just divided, I mean, I just subtracted the difference. That's what I did.
That's fine. But I mean, I think everybody is understanding the concept of like when you go downhill, you're subtracting based on the contour interval.
Yeah, that makes
Uphill,
sense.
you're adding.
Yeah.
And you know, one of the most important things is streams flow downhill. So if your answer was the opposite and that contradicted the rule of V's, that would be a problem. You should notice that that's a problem.
Yeah,
Cool.
I get it.
Should we go to the next question?
I'm ready.
Ashanti, you with us?
Oh wait, actually, I just got back here.
Wait,
Sorry. Do you think-
can you explain how'd you get 55?
50. Just 50 is the difference. Yes, sorry, someone said they just arrived. Did you have a question?
But I'm
Yeah,
trying to-
I just got back here. Do you think we could go over the one you guys went over?
We
But I
will.
don't mind going back if we want to move forward.
Okay. Ashanti, you finish your question, please.
I
You were
just
asking-
wanted to figure out how you guys get 50.
Just subtracted 25 from 75. So the elevation difference is you take the lower elevation away from the higher elevation. So that one was at 25.
How'd you guys get 50?
75 minus 25. Think about it, like I say, the best way I can do to think about it is think about it like quarters. You got 75 cents over here and a quarter over there. You're going to take the quarter out of the 75 cents. You're left with 50 cents.
Okay, I see.
If that's kind of easier for you to think about it. Okay. So,
Wait.
person who just got here, I didn't see what your name was. Is it Lizeth?
Yeah.
Is that how you say your name?
Yeah.
Okay. What question do you want to work on some problems before this or this one?
I think someone else arrived too. I haven't asked a question, but I also have a question about part number 3.
Okay. We will come back to that, please. I think you're talking about this one.
No, the one that says complete quadrant.
Oh, we're getting there. We're
Yeah.
almost there.
Oh, okay.
Okay, so we just finished this one. I think we've answered all the questions.
Actually, sorry,
Oh.
I also just got back here. Do you think we could go over the one that you guys were just going over one more time? But I don't mind moving on because I know you guys just worked on it.
Which one? This one or this one?
The one with like, it has like the big 25 on it, and it's asking what the contour interval of the map is.
The big 25 on it. I don't know which one that is. Is
It
it?
has like 2 pictures and
Oh, yeah. Are you looking at the screen right now? The screen?
yeah.
Okay, yeah. I can, we were just finishing up, but I can explain this one. If you've gotten this far, it'll be quick.
Okay, thank you.
Okay, so I'm just gonna for everyone who has been here, just bear with me for a minute while I re-explain what we did, and then we'll move on to the next question. Okay, so for this one, I don't know why there are two maps now. I thought maybe it was they were slightly different, but I don't see that now. Okay. Okay, so what this is saying, here's another piece of this map. It's saying, note that every fourth contour is heavier and it's labeled with the elevation or the heights in feet. So we have the 100-foot contour that's bold. It's like this bold line, and a 200-foot contour that's in this bold line, right? And on the other side as well. So this will be also 100 feet on the other side of the valley, because there's a valley here. We know that because there's a stream in it. And so you go down a valley and up the other side. So that would also be a 100-foot contour. This would also be a 200-foot contour. Okay. Stop me if I'm going too fast. So we have the 100 feet, we have 200 feet, and we've got 1, 2, 3, 4 contour lines in 100 feet. That gives you your contour interval. So every contour is how many feet different than the one before?
Isn't the contour interval 25, right?
Yes, 25. So you would count 1, 2, 3, 4 contour lines in 100. So 100 divided by 4 is 25. So every line, so in that, it makes sense because then you can count 100, 125, 150, 175, 200.
Oh, okay.
Okay?
Yeah.
Okay, good. So it's 25 feet. We're going uphill because we know there's 100, that's 200. We're going up, we're increasing in elevation. And it would go down from 100 to the stream valley.
Mm-hmm.
Okay. So then it's asking us, what's the elevation difference between the two red arrows? Using the rule of V's that you applied in the previous questions, we know that a V where a contour line forms a V, the V points uphill or to higher elevation. Here's one of those V's at the right-hand red arrow. So this stream, the contour is forming the V and pointing south. That means the stream is flowing which direction?
It's going like to the right, right? Or down? Or no, the V is going up. Sorry. So it's the opposite way of what I was saying.
What?
So
Try that again. If the top of the map is north and the bottom of the map is south, this would be west on the left, or you can say left, or right is east, but the V is pointing to the south. So at this point, which way is the stream flowing? South or north?
North?
Yes. Right. So it's pointing to the open part of the V. So uphill is the point of the V, and then it flows out the opening of the V. Okay, so uphill is over here. So the elevation at this red arrow should be higher than this red arrow because we're going downstream. And water always flows downstream, so that should be lower elevation. Okay, that's just some of the logic to help you kind of cross-check your answer. We're gonna count the contours and everything, but I want you to like think about the logic so that you can catch yourself if you make a mistake. Okay, so here's a 100-foot contour right here by the red arrow. We're gonna count down in 25s from the 100. So 75, 50, 25. Does everyone see that on my screen? For those who can?
Yeah.
Okay, so that red arrow is at 25 feet. The red arrow at the right-hand side, let's follow that 100-foot contour. Here, I'm gonna blow the screen up again so it's easier to see. Again, this is like the same thing. This is one reason to work on the electronic document so that you can zoom in and see this stuff more easily. But here's the 100-foot contour, comes around like this. It's right here. So we're just the next contour down. So that's 75 feet. And again, we know we're going down from 100 because the uphill is to the left and downhill is in the stream valley, because that's why the water is there. It flows downstream, downhill. So this is at 75 feet. That's at 25 feet. So it's higher elevation on the right and it flows downhill towards the left. And then the
Okay.
question is simply, what's the elevation difference between the two arrows?
Okay, so it'd just be 50. And then,
50 feet. Yeah.
okay, cool. And then for the first question, just the answer is just 25, right? What is the
25-foot contour interval. Yes.
Okay, thank you.
You're welcome. So for the folks who just arrived, is everyone cool with this question now? We can move on, or are there more questions? We can take the time to answer them. Don't worry. We're going to go back to the earlier part of the lab after we finish the end. Okay. Silence means, okay, we're going forward. So tell me if that's not the right interpretation. Here's the next question. Okay, I think this is another part of Seattle or something. Okay, whatever. It says the contour interval on this map is 25 feet. And I'm just glancing at the map. I see a 200-foot contour interval and a bold red line here. And that's marked on this side as well. Okay, and that probably is the same as this. So it looks like it curves around just off this map. And this is also the 200-foot contour on this side. Everyone agree with me?
Yeah.
Okay. Another reason I am assuming that that's the same elevation as this side and this side, even though the line goes off the map, is that it's also a bold contour. It's this index contour of, so it's got to be 100, 200, 300 feet. And we're also moving away from a depression. The lake fills a depression, a low point. And so all the contours away from the lake should increase in elevation, at least for a little bit. So that's why we're going to assume that the heavy contour is 200 feet all the way around this lake. Everyone good? So the approximate elevation of Green Lake on the map. Okay, so we've established where the 200-foot contour line is, and we know that the contour interval is 25 feet. You guys figure out what the elevation of Green Lake is. And someone volunteer what that is, please. It can be an estimate, that's okay.
Is it like 125?
Not quite that much.
Because it's
Where are you
going,
counting? Where are you counting from? I assume you're counting from the 200-foot contour.
yeah, and then there's 175.
Okay, so I'll start over here. 200, that's 175,
Yeah,
and then you're at the lake.
so we don't count anything other after, like after 175, so it's 175.
What it means, if there's not another contour line, it means that the lake is at an elevation below 175, but above 150.
Ah, okay,
So it's somewhere between there. We don't know exactly.
okay.
Does that make sense to everyone? Or does anyone have a question about how we figured that out? Okay. Next question. Let's see. Find the contour line, blah, blah, blah. Oh, so it's just giving you. All right, so I explained that. The lake level must be below that contour line elevation, but above the next lower contour elevation. That's what I said. So it's below 175, but it's got to be above 150. Okay. Which corner of the map shows the highest elevation? Okay, first of all, we learned something about the contour lines, and that when they're spaced far apart versus when they're spaced really closely. So there's one corner of this map that is steeper than the others. And so it might gain elevation faster. And so that might be where we go first. So can you tell me where the steepest topography is on this map?
Is it on the southeast?
Southeast would be over here. Is that what you mean?
Uh-huh.
I see these over here. The southwest or
What about northeast? Northeast seems pretty.
those are also closer. So it gets steeper here, but these are the closest spaced contours over this side. See how, I mean, they're tiny. They're only millimeters from each other, right?
Mm-hmm.
Okay, so I wonder whether the topography is going to be highest in that corner because it increases so quickly. So I'm going to suggest starting to count the contours to the edge of the map on that side and see how high you get. So I'll zoom in so we can count these better. But there's 200, 225, 250, 275. Here's 300. Here's 325. You guys agree with me?
Yeah.
Okay,
Mhm.
325. Now make a note of that, and then we'll come over to the southeast and see if it's the same. So here's 200, 225, 250, 275. That's 275, so 275 versus 325. So far the steeper topography wins, that one. And let's count this side. 200, 225, 250, 275, 300, 325, 350, 375. Oh, I was wrong. And just to be sure, 200, 225, 250, 275. Ah, so it's the northeast corner that wins the highest, that is the highest elevation. I don't remember what I said it was at though. 325, 375? Does everyone count the same way as me?
Yeah.
Good. So you can describe that as the northeast.
Can you
corner.
explain the approximate elevation on the map again? Sorry.
How we're getting there, like how we're counting to the highest elevation?
Yeah.
Sure.
Yeah.
So I'm just starting off with the contour that we identified as being the 200-foot contour. So that's this heavy one right here, right? It's not marked there, but it's marked over on this side of the lake and it's marked on this side of the lake. So the contours simply, they just bend around and they come back here. So this is also a 200-foot contour interval. Sorry, 200 contour, 200-foot contour. 200, then we count 225, 250, 275. There's another bold line that's labeled 300. So that number one, that's the next index contour. So we should have probably just looked for the next bold line. It was kind of obscured by that highway. And that confirms that we were right. That was the 200-foot contour that we started off with. So fine. 300, now I'm gonna keep going up because it's still going uphill. 325, 350, 375. So I'm simply counting the lines and adding 25 each time. Okay. Does that clarify everything for this problem? Okay. Silence, I think, means it's
So
okay.
the approximate elevation could be? Yeah, so the approximate elevation could be 375?
375 is the highest corner that I counted, yeah.
Can you hear me?
Yes,
Hello?
I can hear you. I can hear you.
Hello?
I can't, I can hear you. You can't hear me, I guess. Why don't you hang up and call back in?
No, I'm talking about for the approximate elevation.
For It's only asking us to the approximate elevation of Green Lake, you mean? Yeah, okay. So we're gonna count down from 200 feet. We're going downhill towards the lake because water fills depressions. That's 175. So 200 minus 25 is 175. That's the last contour we see before we get to the lake. So what that tells us is that the lake is at an elevation that is less than 175, but higher than 150, because we don't see the 150 contour. So it could be like at 160 feet, something like that.
Hello?
Hello? Can you hear us now?
Yes, I was just trying to see, was the approximate elevation 375 also?
So for this corner, the highest elevation on the map is 375. The first question asks the elevation of Green Lake. We subtract down.
Which corner is that? Would you call it?
The one where it's
Fairview?
marked Fairview. It's by the highway, so upper right.
Okay.
This corner up here, upper right. And the answer for Green Lake elevation is simply, it's an approximation. It's less than 175, more than 150. It's somewhere in that range. Okay. I think I can move on now. Here's a new map. This one has got a bit of, it's kind of simpler, simpler topography to look at, where it's an island that has basically one hill on it, a little point sticking out here. It's got some really steep cliffs on the left side and the right side, especially the right-hand side. There is a building of some sort and a road. It's a very short road. And we have 100-foot and a 200-foot index contours labeled. Let's figure out the contour interval first so that we know what we're dealing with. Oh, it tells us. We don't have to figure it out. But we could, because we're going to count 1, 2, 3, 4, divide by 100, and we get 25, same thing. So its contour interval is 25 feet, right there. Index contours every 100 feet. Okay, so it's explaining that those red numbers, 25 and 36, they refer to another sort of map making section. We don't need to worry about that right now. So it's saying, by now you've learned how to determine for yourself the highest point on Blake Island is between 250 and 275 feet in elevation above sea level. Where's the highest point? Is it here? Is it here? Is it here?
I think it's near the 36.
It's to the left of 36. Yeah, like right here.
Yeah.
So the 200-foot contour interval is the highest elevation we see, the highest contour elevation. We're going to count up 25, 50. So 250 is this contour interval. So the highest point is above 250, but below 275. And now it's got an interesting question. From which direction would it be easy?
Say that again. Can you say that again?
Sure.
The highest point is what?
The highest point, if we look at the 200-foot contour, I hope you're looking at the map at the same time. The 200-foot contour is there. I'm counting up one contour, that's 225. Here's a second contour at 250. So the highest peak, the highest point is somewhere in this circle above 250, but below 275. And then it poses
below 275?
Yeah, that's right. Because there's no 275-foot contour. It's just not there. And, you know, it's not like this hill doesn't have an exactly flat top at 250 feet. It's going to have a rounded top of some kind, usually. So, you know, you're going to have some little hill that is not high enough to go to 275, but that's above your 250 contour. Okay. Which direction is easiest to climb up on Blake Island? If you were going to go to the peak, what route would you take starting from the beach?
Wouldn't it be the left side, the west side of the island?
Well, can you see where I'm pointing?
Yes, that side.
So this looks super steep to me. That
Is
would be the most direct and the shortest route, but that could be really painful and also dangerous if that's a
Is
cliff.
Northeast, like the right side?
Where the
yeah.
building is,
Yeah.
that's where I would go. I would start off here and climb up where the elevation gain is gradual, and then follow around somewhere toward the peak. I wouldn't, you know, if I was trying to get there and I knew that I could climb this, I might not even want to do that just because it's the shortest distance. It still would be pretty painful to climb up there, because it's like it's 100 feet in a very short distance. I think it would be really steep, and so I think the best answer is to come over here from this eastern beach and to work your way up around like where it says Blake Island and then come up to the peak.
I have another question, which is not related to this. Like, what's the height of the other hill? Because it seems to be that there's like, I can't like.
This one, you mean?
Yeah, because the distance between 200 and 100 is like, it's 125 and 150. Is it
Yeah.
150?
It is. So this contour is 125.
Yeah.
This contour is 150. This is also 150.
But it's a hill,
close
right?
at the same elevation as this one,
How do we know that?
because we're still counting up. So if you just start here from where it's labeled 100, 125, 150.
Yeah.
Same as going like 100, 125, 150. Same.
Okay.
But this is an enclosed circle, so that tells you it's a hilltop. So
Okay.
it's like it's got a hill over here that's the high point, and then there's another little ridge and a small hill on the side.
Okay. Got
And
it.
that hill is between 150 and 175 instead of 250 and 275.
Okay. Got it.
Okay.
Yeah.
That's that for that question.
Wait, just 1 second. I couldn't really
we have two
hear.
more. Sorry.
Hello?
Hello, we can hear you.
I couldn't hear when you explained from which direction is it coming from.
Oh, that's too bad. Okay. So I would come from the northeastern part, the top right, where the spacing between the contours is wider. So that when you're hiking up gradually instead of climbing up a cliff to get to the peak. Like this side, the left side, you'd be climbing up a cliff to get to that peak. Even worse cliff down here, the bottom right. But the top right, the contours are spread out nicely. Like not right here, I wouldn't go there. But right here, they're spread out the most. So I think I would start a path this way and move from the top right at that point where that circular road is, and then come up past where it says Blake Island and that number 25, and then I would go to the peak from there.
Thank you.
You're welcome. Okay, last two until we go find your own map. But okay.
I had a hard time trying to figure out to find a map.
We'll do it. We'll get you one. Okay, so the topographic map shows the Isis temple. That's the name of this hill, a butte. A butte is a flat-topped mountain. So this is like a tall, flat-topped hill in the Grand Canyon in Arizona, which is 7,012 feet above sea level at its peak, and that's labeled. Look closely and you'll see that the contour lines are closer at some elevations where there are steep cliffs and more broadly spaced at other elevations where there are gentler slopes. Okay, we've been talking about that already. Now it's going to ask you, how far apart in elevation are the index contours on this map? Remember, the index contours are the heavier ones, the heavier lines. How far apart are they spaced?
400 feet.
Yeah, 400 feet. So you see, here's 4,000, and then the next one up, the next index contour up is 440, 4,400 feet. Okay, so I'm gonna zoom in a little bit and see that there's 1, 2, 3, 4, 5 contours in that 400 feet. So divide 400 by 5. What do you get as the contour interval?
80.
80 feet. So this is, I mean, that's a lot more than the last few maps. So this must be representing a lot steeper topography than we were just looking at. Yeah, so the answer to the first question is 400 feet between each index contour. The contour interval is 80 feet. It says between, how many, it's saying how many contour intervals are there in between the contour lines. There are 1, 2, 3, 4 in between the index contours. But remember, when you're dividing, you need to count the next index contour as well. So you'd be dividing that elevation difference by 5, not 4. So that one's worded a little bit funny. Okay, approaching from the south, the steepest cliff occurs between which adjacent index contours? Okay, approaching from the south. Oh, okay. So go between the N and the A, in which I'm assuming is the word national, like Grand Canyon National Park or something like that. But move north on this map, so up, and look to see where you see the steepest topography. I'm going to zoom in more. Okay, that means, and this is saying between the index contours. So we're just looking at the bold lines. So we want to find the narrowest spacing between the index contours there. Where do you see that? Is it this next to creek, or is it this point up here?
That point.
Yeah, I think it's the point. Those index contours are really closely spaced. So that's a huge cliff. Okay, so which index contours? So which index contours are those? We need to add 400 to get this one. So this is 4,800. And this is 5,200. Add another 400. Got it? So the lower index one is 4,800 feet. The top is 5,200 feet. Does
In the
everyone
middle.
understand how I got that?
In the middle.
Yeah, in this middle point that's pointing south between the N and the A, that's where they're most closely spaced. So those are the steepest cliffs, is what it's saying.
So what would you call that?
I'd call it the southern pointing point. I don't know. The southern the southern point facing south or something like that. I don't know. You could draw a circle on your map. I don't mind. You can describe it how I said, between the N and the A on the map, and south of Isis Temple, between the peak, south of the peak. So that's why sometimes drawing is a lot easier, because you could just circle that point and draw an arrow to the question and
Wait.
give the index
So
content there.
there's 4,400 and then
We're
right
going
there,
up, we're going uphill. That's, we add 400 because
and
there's
it'll be 4,800,
800. Yeah,
and then in the middle will be 5,200.
yeah.
Okay.
Great. We're making progress. You guys are getting better at this, which is excellent. Okay, last question before we go find your own map. Okay, I think this deserves some zooming in here. This is asking us, this map shows a sinkhole region in Florida. Oh God, there's sinkholes everywhere in Florida. These are places where it's like limestone is the underlying rock, and sometimes the groundwater actually ends up dissolving some of that rock to form these underground caves that you can't see. They're under the surface, and occasionally the surface will break out into one of these caves, and that's called a sinkhole. So here's some of these sinkholes here and there, where you see those hatch marks. There's some more in the bottom center, the one on the bottom left. There's one, Lake Bell is filled in one of these sinkholes. All the lakes are in a sinkhole. Okay. How far apart in elevation are the index contours on this map? I see a heavy line that's labeled 150. I see a heavy line labeled 175.
25 feet.
Yeah. So that makes the contour interval for this map how many feet? So it's 25 between the index. We've got 1, 2, 3, 4, 5 lines. So divide 25 by 5.
5.
5. So the contour interval is 5 feet. What elevation is the bottom of the sinkhole that the arrow 1 is pointing to? Okay, so we've got this is kind of handy because we've got the top of the sinkhole marked at 175 feet, and we're going to count down in 5s from there.
So it's lower than 150?
Yeah, because these hatch marks tell you we're going down in elevation.
Yeah.
So anytime you get a bowl-shaped feature or a crater or something, you're going to get these marks on the lines that tell you count down in negative elevation. So 175 here, 170, 165, 160, 155, 150. Somewhere below 150, but above 145. Does that make sense to everybody? You guys tell me what the elevation is the bottom of sinkhole 2 or sinkhole 3. Sinkhole 3, please. You guys figure that one out.
Are we starting at 175 still?
Well, it depends on where you're counting from. If you start from the 175-foot contour, sure. So if you start here, 175, this line is 170, this line is 165. That gets us here. That's 165. I think this is 165. That should be what? 160,
155.
155. So somewhere below 155 and above 150. Yeah, same idea. Okay, that's not a sinkhole though. That's why I stopped myself, because I realized there's no hatch marks there. So that's not a sinkhole. What is that feature? Two.
It's a hill.
Hill?
It's a hill. Yeah. Good. You guys are getting good.
So for that answer, it's not a sinkhole, right?
But it's not a question either. I just asked you just to see if you guys were understanding correctly.
Because I don't really understand what elevation is the bottom of the sinkhole of the arrow pointing to.
Number 1 or number 3 or both?
The number 1.
Number 1. Okay. So we
I
have
mean number 3.
okay. Number 3. So we just need to figure out what these contours, what the elevation is, right? So let's start someplace we know the elevation. Here's 175. We're going to count down in 5s. 170, 165. This is the 165. I'm following it around to that sinkhole. 165. Then we go down. 160, 150.
So it'll be 150.
Yeah. Basically, you just start counting down once you find the top, once you can get the top of that sinkhole. Then you just start subtracting your contour interval for each contour. Okay.
So it's pointing down to 150, right?
Yeah.
Okay, I see.
Okay. We're done with that part. Yay. Okay. It's past 11, it's past 1, but I don't mind finishing this off and just like getting you guys done with this lab. So let's, and plus who knows if someone will show up. This one requires you to go to this link and find a map of your own. And I'll show you how to do that in a second. This is asking you several questions. In this part of the lab, you're going to use an actual topographic quadrangle. And I asked you to pick your own. So it could be where you live now. It could be where you grew up. It could be some place in the US that is interesting to you, like Yosemite Valley. We can do any of those things. You can choose. And then you're going to answer these questions about that map. You're going to find out, well, some of these are general and some of these require the map. You're going to answer some questions about the maps are labeled in latitude and longitude. Lines of latitude are the horizontal lines that encircle the Earth. So that's sort of east to west. And lines of longitude go from the poles of Earth. So they're north-south facing lines, directed lines. And sorry, go ahead.
I have to go now. Thank you for everything.
Oh, you're welcome. These are, you can Google the answer to some of these questions to figure it out if you can't figure it out on your own. Or you can ask questions in class on Tuesday, okay? Or send me an email.
Thank you. Thank you so much.
Okay, goodbye.
Bye.
Okay, so arc seconds in a degree. What I was about to say is that there are, we do this in degrees. So there are seconds and minutes within degrees. So if you assume that a degree has 60 minutes in it, a minute of map distance, it also has 60 seconds within a minute. So there's 60 seconds within a minute, there are 60 minutes within a degree on a map. So how many seconds are in 1 degree? You just multiply those two numbers. 60 times 60. And that will give you the number of seconds in a degree of map space.
So
This will make more sense when we start working with the maps. It's also
60
gonna,
60 divided by 60 to get the arc.
multiply.
Oh.
60 times 60. If you took a magnetic compass and went on the quadrangle that you're looking at, we'll answer this question when we pull up a quad. there's going to be a north arrow and there's going to be a magnetic north arrow. We'll look at that together so I can point this out, because our geographic north isn't necessarily where our magnetic north pole is. Our geographic north is here, but the pole is off by, you can see my finger, is off by a little bit. And how much it's off by depends on where on Earth you live. So let's go find a map and then we can start looking at those things. So I'll go here, I'm gonna open the link and I'm gonna have to switch you over to share a different page. Okay. Let me share this. Okay, here we go. This is the page that you open. You're free to like go grab your own right now, but right here under graphical indexes, you see USGS Map Locator. Click that. You're given a map someplace in the US, but type in the location name or the address. Like I put in the address of my house, and it did a great job of finding exactly what I needed. So if you guys want to share an address with me, I can help you find your own. Go ahead.
Well, right now I'm living at SF State.
So you want to do 1600 Holloway Avenue,
Yeah.
San Francisco. You're really on campus.
Yeah. And the new ones. Well, right now I'm at my grandma's house.
Oh no. Wait, oh sorry, that wasn't an oh no about your grandma's house. That was an oh no, it says the service is unable, it's like not available right now. We might not be able to do this right now. Oh no. I think it must be offline for some reason. Here, let's try this other one. Something on.
Someone said they're getting that notification too.
Oh yeah. Oh, in the chat. I'm not looking at the chat. Yeah.
I can try it later.
Yeah, this might be a try later. All you have to do, so what I did was basically, let me just explain before you go. I put in my address here, like a street address and everything with the city, and it up popped the name in just in black type. It wasn't like real obvious, but just right underneath this search field, the name of the map popped up. I clicked on that and it took me to the right place, and you got to zoom in until you can see exactly where the pointer is pointing, and you'll see these green rectangles with a name in green at the center. Those are the quadrangle or the map names and the map areas. So you want to find where your pointer is pointing at, get that quadrangle, and put the name of the quadrangle in this locator. Then type the name, like I happen to live on the oh, it's not going to do it. My quad is called Montera Mountain. I'm in Pacifica. So when I type in Montera Mountain, it takes me to a list of Montera Mountain topographic maps. And all I have to do is pick like the 2018 one, whatever is the newest map. And I can download that for free. And then you answer questions based on that map. Does that make sense to everybody?
Does it have to be the newest one, or can it be like from another year?
If you want to use a historical one, I suppose, but the roads are going to look different. The buildings are going to be in different places. So that's why I suggest using the current one. But if you wanted like to look up your street address when you grew up and a map that was done at about the same time, go ahead, find the 2000 map or whatever.
Okay.
I'm not sure how to figure out the difference between the magnetic north and the geographic north on this map.
Let me find you an example. Okay.
Oh, I think I know. I can probably figure it out.
This should be a little diagram popping up here in a second. Here we go. So look at this. So this has 2 arrows. So at the bottom of your topo, you'll see something like this, where there's a north arrow that should point straight up. That's your geographic north, and your map should all be oriented to geographic north. But then you're gonna see, that's what GN stands for. MN stands for magnetic north. And oftentimes it's actually listed magnetic north. It doesn't have these abbreviations. But this other arrow tells you magnetic north is offset by almost 14 degrees from geographic north. The reason that matters is when we use a compass on Earth, and there's what's called a magnetic, this is what this is called is a magnetic declination. The word is right here, magnetic declination. That tells you that when you're using a compass, that your compass reading, it doesn't go to geographic north, it goes to magnetic north. And so you have to make a correction if you were to be if you're trying to go somewhere in particular, you need to make sure you correct for magnetic north, and so you're actually going north. That's what that refers to.
Okay, thank you.
You're welcome.
I'll just email you if I have any more questions.
That sounds great to me.
Okay, thank you.
You're welcome. Anyone else have questions before we go? I'm just looking to see.
I just have a, oh, sorry.
Oh no, it's okay. You can go.
Okay. I just have a question about the question below the one that says, if not, what's the name of the difference between magnetic north and geographic north?
Right.
It's on the lab.
Okay, let me go back to the lab. Sorry. Share. Okay. Okay, so you're talking about these bullet point questions.
Yeah.
Okay, so
The third one?
yeah, the third one?
I mean, the fourth one. Sorry.
Fourth. 1, 2, 3, 4. To find the contour interval used on the topographic map. Sorry, it didn't even say that. On the topographic quadrangle, would you need to find the elevation? Is that the right question or the third one?
No, that's the right question.
Oh, okay. Would you need to find the elevation difference between index contours and divide by the number of contour intervals between index contours? Or is there an easier way? If so, describe the easier way to learn what the contour interval is on the map. Yeah, it's usually labeled in words. It is that simple. Yeah, at the bottom, there's a lot of information at the bottom of topographic maps. So when you get to the questions down here, like what's the name of the map? Who published it? What's the publication date? How much difference between the magnetic north and geographic north? It's on the edges of the map. You'll find all those answers. The name is going to be at the top, but the geographic north, magnetic north, scale bars, contour intervals, those will all be at the bottom.
Oh, okay. So it's like basically it's asking like, where can I find that information, right?
It's basically saying, instead of figuring all of this out and dividing and doing all this math, just read the map, and it says contour interval 20 feet. That's how you find out. That's literally it.
All right. Thank you.
You're welcome. What was your question? The other question.
So I know this is being recorded. Is this going to be uploaded to the iLearn?
Sure. Yeah, I'll upload it. Oh, yeah, that'll help you with the earlier questions too, of course.
And then also, is this like study group thing going to be like a one-time thing?
I'm thinking we need more time every week. Because the labs are taking you longer than I expected. And it's on me. So we either, like my email said, like we either need to start coming to class at 9:30 and stay all the way till 12:15 to do this, or we need a third time that we're gonna meet. And so this worked out for a few people anyway. I'd like to talk to more people in class on Tuesday and find out if this is a good time, or is Monday better when you've had the weekend to work on your labs first, something like that, you know? We could try in the evenings, we could try in the mornings, lunchtime, you know, I'm flexible.
Okay, that sounds good. Thank you.
You're welcome.
For the other lab, I think it's number 2. Are we going to work on that like throughout the weekend or during class?
I think that one you can start on your own for sure.
Okay.
That one is going to require a good internet connection so that you can go online and you're going to watch a video of Lisa White, who used to be on our faculty in our department at SF State. She now is the director of the Paleontological Museum in Berkeley. And there is a video of her explaining the fossils that are found at Kettleman Hills, and that's the basis of your lab are these fossils at Kettleman Hills, which is down by Coalinga. It's like off Highway 5 south of here.
Okay.
Please start it before class. Even if you don't answer a single question, it'd be great if you could read a little bit, go to the website, watch Lisa's video, see how far you can get. We'll certainly talk about it on Tuesday, but I have a feeling, yeah, I'm either going to have to pause on new labs until everybody catches up, or we're going to have to do something to adjust.
All right.
But I intend for you definitely to be spending some of your own time working on the labs. So see how far you can get, okay?
Okay. Thank you.
You're welcome.
Okay, well, thank you so much, Professor. Have a good rest of your weekend.
You too. And you really can call me Mary. It's okay. But
oh yeah, of course. Sorry.
But yeah, good luck on finishing this up. But don't worry if like you still have more questions. If you don't want to submit this until next week, that's okay.
Okay, thank you so much.
Okay.
Thank you.
See you next week.